Hello. So you see the motor control diagram. This is from Facebook post actually. Okay. I need to tell that I am actually interested in his post, and he has written a book. So I just follow him. See his graphic and the wiring, the programming, and then put it in other language, how we can do that. So everything in one image, and I like that actually. So that's why I'm just why this thing is there. How to show this? I have to log in. I don't want to log in. So anyway, okay, here it is. So you see the ladder equivalent of ST language, the structure text, and then this is the flow chart of this program, and this is the wiring diagram, how you actually do the wiring of the push buttons, start push button and then stop push button. And amazingly, if you see the kind of details he has, it's nice to have in your program. If you write program, give comment like this: motor start contact no. The start button is the normally open push button, and the stop push button is the normally closed push button. The difference is normally opens means when the push button is not activated, then it is normally open. That means it's open circuit, so the signal is not going to the PLC. The 24-volt signal is not connected to the PLC input, so input is false, 0. But other case, for stop button, it is normally closed. That means the 24-volt is connected to the PLC input. The circuit is closed, and it's a true signal in stop input is true. And then K1 is the motor relay, that is the output here. If you see, is the connected to motor contactor or relay. It's shown here directly to the motor. It's okay for understanding. But the basic, beginners might be confused with this kind of diagram. Output is connecting directly to motor. Normally this never happen, that output is connected directly to motor. There should be some understanding for this one. For those who knows already, for them it's no different, because they understand it's just for making example simple. Not to make clutter here, make relays and contactors and so on. So it just indicates that this output drives the motor. Okay, but the real wiring is different. I would tell you, if you come to my training, I can give you the details and all this thing. Now here is the simple program. If B, then K1 true. K1 is the output for the motor relay. Here is the little relay. You see the motor relay is mentioned here. It's not that motor is directly driven, but instead it's driving the relay, and then relay further runs the motor. So this is done. So if B1 means if B1 is pressed, then K1, the value assigned is true. So even if B1 become 0, it doesn't matter, K1 still will run, continue. So that is the if logic. If not B1, so here for stop is different, right? So stop is before pressing it is already 1. So now to make it stop, you have to make it 0, disconnected. So when you press, it will disconnect. So that's why if not B1, that means disconnected. If disconnected, then stop button activated. Okay, so if disconnected, then K1 is equal to false. So that means stop the PLC. Now if you release the push button, it will be true again. So it will be connected again. So it doesn't matter. So you see the false value is already assigned to K1 unless you press the start button again. the value will remain false. So that's the program. So let's do this in our real TI portal. I have already opened. Okay, so here is the TI portal I have opened, and I want to create maybe I want to use this one, but okay, here just new project. So it's a motor control. Okay, so project is saved here. It's open. Go to project view. We can start this way also, but I prefer to go there. My habit is directly go to the project, and from there insert the PLC. These softwares actually takes time to open the beginning, but once it is fully open, then working with the folders is much faster. But anyway, this is always like this. When I start to create a project from the beginning, it takes time. Okay, so now I have to insert a DIDO module. Insert here, second slot. Okay, so now I have installed that input output module. I can double click it to open the tag. I can give input. Okay, so now the difference between that theory and its practical programming is different. In push button start, PB start, I have defined this 0.0, and then I write PB stop, this is 0.1. If you have motor that has feedback from the contactor or relay, then you need feedback as well, whether the motor is running or not, to check that one. So in that case, you continue to add feedback motor or something like the feedback motor running. So that's the one. That means when the motor is running, then you get the running feedback. And what else? You don't need much here. So that's the difference. Practically, most of the time you have feedback, and then you have a motor, right? Nothing much here. You might need sometimes indication for different output, like motor is actually running to show that one. But usually that happens from the contactor. So contactor will have auxiliary relay contact, and from there you connect the indicator. I'm not adding that one, so I just wanted to say the difference. Go to the program block, and you can write program within the OB one, but I prefer from the beginning to have a structured programming. So I've always intend to create a block first, and then function, I write the ladder instead of that SCL. If you select the SCL, you can do that if you want to write. So open this SCL block and write exactly what you have seen there. So what you have seen here, if you see, we have 3 variables and then program that. So if you have 3 variables, one is start bool and then stop bool and then feedback. Okay. So that's the variable name. Output variable is only motor. Okay. Now here this language is very, it has this template. You can just click it and it will be inserted for you. So that is start. If start, okay, you see the start, then here you can assign something like motor. You see the output is coming Q 0.0, true, right? That's done. Start is done. Then another if. Now this is this time different. If not stop, because stop, you remember, it is a normally closed push button. So it's from beginning it is already high. So we are looking for low. When it is low, when it is low, if not stop, then assign motor at Q.0 equal to false. That's done. Okay, and stop is going to stop only when running, not really. We just want to stop this one. We do not have any use for this at this moment, but if we want to raise alarm, something like, you know, if let's say use if motor, this one, and not feedback, this one. If motor is turned on and feedback not, you know, didn't get the feedback, then something we can do is raise alarm here. Fail, feedback fail, right? Such kind of alarm we can generate. Feedback fail equal to true. But this should be done after, you know, few seconds, like 10 seconds, because after you actually command to run the motor, it has to trigger the relay, and then relay further have to turn on cascading effect. Takes time, maybe 1-2 seconds is okay, but for precaution take 5 seconds. This one space. Okay, so feedback fail. So feedback fail, you get this. But when you have other way around, you have feedback, but or you can say something like this, or this is practically you have to create logic like this to fail safe your logic. So if not motor is not turned on, but you get the feedback. That's another behavior of the relay. It may happen. So this is also true. In both cases, it is true. And another case, when to reset this fail thing, you have to reset it when motor is off. Motor is off, or you can reset. Yeah, motor is off. You reset this thing false. But in case again after reset it gets into this logic and see this is true, then it will turn on again. So that's a thing. That's it. So every time it stops, it will also says the feedback fail signal. But this is not the right place actually, because even if you stop and you get this alarm, then anyway it will be true, right? So what we can do, we can write another logic, something like if motor is running and you get the feedback. Then you reset. This is more proper. Motor, this should be feedback local variable, because we have to use this. I'll tell you, we are writing the program inside FC1. So we are not using any real variable inside our program. We should not use real variable here. Instead, we are using the variable declared inside the FC, and shortly you will know why it is. So this symbol indicates they are local variable, declared local variable. Okay, and how to make sure that everything is so tag information. Okay, so you see all this is local variable, but if you remove this, what we'll get, you will get something like motor and motor feedback, and something more we can do here. So tag information with hierarchy command. I should get actually the address here, not showing. You see the bracket, that means it has actually address assigned to it. So we just comment it out and it's gone. To save it, okay. So what we can do now, we can open the OB1 and call that block. Okay, so here is the thing. Okay, this is so go to instruction general and empty block, and I can write the name of the block as block 1, right? So this is the FC1. We have written the program begin. So here actually I can give the push button start, and then this one is push button stop. This is back, and this is motor. This JM 2.0. It can be data block bit, memory bit, is input output, that means it is all input, sorry, and these two are outputs. Draw inside block in this variable name, and then they are used in the program. How it is, and hope you enjoyed it. We can compile, things like that. So some of the warning you see here, parameter motor might not. Okay, this indicates that some of the variables are not in. But it doesn't matter actually. Your stop push button is normally connected, so it is going to initialize immediately when it starts the program. Things usually used, and this is used place for initializing the variable. It's not required too much as per our logic. It should. Why is this full output? This is not actually proper, thing. It can be, underscore. Dash is normally not used. So, role. So here is good. Now this I already talked about. You don't need to initialize it. Thanks, and see you in the next video.